Great.
Okay, we're going live now. Yeah. Hello, one and all. Welcome to another splendid afternoon with the fourth edition of LinkedIn Live. Thank you so much for joining us, Alan Sebastian, and I'll be your host for the day. Jumping right into what we have in store for you. Today's session is about decoding the Industry 4.0. For 2021's first session, we wanted to talk a little bit about what the future will look like and take a sneak peek into discussing a few interesting topics like what will the next industrial revolution look like, and what will this mean for the manufacturing sector, and obviously how Affine is leading the path with next gen technology. So without giving away too much of what's to come, let me welcome our guest speaker of the day, Mr. Ravi Teja. Hi Ravi, thank you for joining us today. All right. So to give the viewers a quick intro about Ravi, Ravi is a senior principal at the Manufacturing Center of Excellence at Affine. The Manufacturing Center of Excellence is a relatively new wing that combines the applied research from AI and analytics engineering center of excellence. It's dedicated to advancing the manufacturing sector, and Ravi Teja is a lead superstar who plays a key role in the latest doing it. Right? To know more about all the things that we do here, why don't we ask Ravi himself? Ravi, what do you say? Can you tell us a little bit more about all the cool things you guys do at the manufacturing theory?
Sure. Thank you for the wonderful introduction, Alan. Right. So thank you all for joining us here. I'm glad to be part of this. Right. As I'm Ravi, I represent manufacturing COE at Affine Analytics, and uh, manufacturing is one of the focus areas for Affine. And I'll today touch upon some of the work we have done in this space. Right. And at manufacturing COE, we closely work with industry folks to understand what is happening at the shop floor, the production shop floor, and optimize some of the processes for the manufacturing in the complete value chain, and bring in AI and analytics intervention and customize as per the requirement. So that's on a high level what we do, right? And
Right.
during the when I have some slides here to show it to you guys to give it some structure, and I'll today will be a basic session where we'll cover what is Industry 4.0 and what is some of the work we have done, and the framework details of it, and that's how the flow is gonna be. So we'll keep it short,
Okay.
and yes.
Thank you, Ravi. That's wonderful. Do you want to jump right into the reasons for today's LinkedIn Live? Let's decode the Industry 4.0. What do you say?
Sure, definitely. That's how
Yeah,
we should go. If you can probably share my screen, that would be a good place to start.
definitely. Just
I have
Ravi,
some
we'll bring
slides.
you up.
We can go live with that. Yes.
Sure, sure.
Okay. So what is Industry 4.0, right? It's a notion, it's an idea, it's a reality, right? As we speak, Industry 4.0 is revolutionizing the manufacturing industry, right? So how did we get here, right? So starting in late 1700s, thanks to Sir James Watt with the invention of steam engine, this was the first time we moved from farms to factories. We started using power of steam for textile looms, for transportation, for iron production, so on and so forth. Right. Then came in early 1900s, thanks to Sir Henry Ford. This time we had assembly lines, and we got into mass production of cars and different consumer products. Right. And
Right.
I'm sure a lot of the folks out here would have seen these different videos and pictures of car mass manufacturing from GM and Ford plants, right? Okay. Moving to 1970s, we have computers, automation, electronics. You can hear me? Is there some glitch?
We can hear you. Yeah, I can hear you at least.
Okay, okay. So this is exactly the problem which I'm gonna address today. The kind of power glitches sometimes happen because of the changes in the industry, and how do you address them with uh, some of the work which we do with AI analytics and all of that, right?
When
So
will
right.
finally
So
technology
we're
make
at
life
Industry
better, right?
3.0 and introduced, and then we had automation, we had robotic arms, and we could look at optimize. Yes, exactly. Could look at optimizing some of our processes, right? And now we are in current stage where we are bringing together the physical world and the cyber world together, right? So like any digital industry, what we see now is interconnected machines, smarter factory, and we're trying to leverage different technologies like cloud, big data, analytics, AI, and so forth. Right. So this is where we stand now, and we're trying to leverage some of it. And I'll go into details of what exactly Industry 4.0 means. Right. So yeah. So start off with. So let's address some of the industry challenges. Right. What are the challenges within industry? So first could be scalability. So what is scalability in terms of manufacturers, right? So let's say Toyota figures out in Japan in the car factory that they have to solve this problem, right? Can they replicate the same problem in US now in their other factory? It's not very easy. Why? Because we're looking at a brownfield environment, and some of these machineries here are around 10 to 15 years old, and in some places it's 30 to 40 years old. So what that causes is the interconnectivity between these machines and the conversation between these machines is not very easy. Then there is definitely global competition. So the local manufacturers don't have the advantages anymore. All the global players are participating in different geographies. And then we have high capex. So what do I mean by high capex? There is very high investment required for even the smallest of projects which we do, right? Especially in manufacturing context, because the machines are very expensive which we need to develop. Then we speak of hardware complexity. So within a factory setting, there are sensors, there are machines, there are machines like CNC machines, there are shapers, there are stamping machines, welding machines, right? There are ever increasing complexity. There is PLC, SCADA. So how do they talk to each other, and what kind of protocols do they use, and is the protocol able to converse with different versions of these machines, right? And at the end, labor is not very easy to find. How do you find this labor? How do you train this labor, right? And can you automate some of it? That is what we can look at, because finding labor is expensive and not easy to skill the labor, right?
Right.
Okay. So, some of the facts which we'll look at from the research agencies. So, a study says there's close to around $50 billion which manufacturers lose due to downtime of the machines, right? That's a big number annually which we're going after. If we can fix some of this would be huge gains for these manufacturers, right? And some of the challenges what we have seen, if we can address using Industry 4.0 framework, we can impact the economy, the global economy, by close to around $4 to $11 trillion. This is by 2025. Right? So these are some big numbers which we are trying to go after. Right? And that's the idea and the framework of Industry 4.0 is addressing. Right?
Okay.
So going into the details of Industry 4.0 framework. So this is there are 4 steps to it. The first step is connecting the ecosystem within the factory. That is vertical networking, we call it. So when we speak of a factory or a manufacturing setup, we have sensors, right? We have temperature sensors, pressure sensors. We have probably there could be light, there could be smoke, different kind of sensors. Then there could be machines, which could be again shaping machines, drilling machines, boring machines, welding machines. Now, are they talking to each other or not, right? And or are they operating in silos? So idea is to first integrate all of them, ensure that all the components within factory are talking to each other well, so that optimizations can be built on top of that later. Second is the horizontal integration. So when I speak of horizontal integration, does my factory know what is my sales up to, or what is the demand from market? So we are talking about the value chain integration here, so that I can customize my production based on the market demand, right? And let's say in the times of COVID, when there was a outbreak of this virus, right, there was suddenly drop of raw material supply from China. So if you're not monitoring some of these very closely, your factory could uh, keep on producing, and if you don't have raw materials, right, then there could be a time that you'll have to shut down the factory, probably because you don't have the raw materials from China.
Right.
So those are the challenges you can solve by horizontally integrating the value chain of the business. right? Third
Sure.
is engineering across this value chain, that is seamlessly integrating all of it so that consumer and product life cycle is all connected and all of it can be leveraged. And then once all these three steps are done, we try to leverage all of them and accelerate using the new technologies, right? What are the new technologies? They're here. So big data, and using big data, you do analytics in AI, which is one of the biggest levers. Then there is
Yeah.
cloud computing and storage. Then there is security. Security is definitely one of the big concerns for the manufacturers, because some of the manufacturers are taking the data first time to the cloud, so they have their own set of concerns there, right? Then we're looking at automating some of these processes using robotics, right? And then we have AR and VR technologies which are used for simulation. And definitely at the end, there's additive manufacturing, which is the 3D printing world, right? So what do we gain from this at the end, right? So we gain improved productivity, reduce failures, right? Reduced failures obviously means less downtime of the factory and more uptime, which reduces cost, gives better experience and better margins to the business at the end of it, right? So that's how we gain from Industry 4.0.
Okay.
Okay. So what are the emerging themes, right? So when we talk to a lot of our customers, they uh, they talk about predictive maintenance, because this is one of the biggest use case of AI in manufacturing. So this is where you try to preempt and predict if there's a maintenance kind of a scenario which is coming up. So let me give you an example. In a car manufacturing kind of a setup, right? There is a steel. It starts off with a steel rolls or a steel coils, which are then straightened out and then they're stamped using presses or hydraulic presses. Then they are given a shape of different body parts, right? Like fenders, it could be bonnets, it could be the
Right.
roof
Yeah.
of the car, right? And then they're put together using the welding, and then you paint it, and then probably put engine into it, the transmission into it, and at the end you have the tires, the electronics, and there is a test towards the end before it is shipped to the nearest distributor, and the consumer takes it over, right? Now in this process, let's say there's a problem with the stamping machine, right? Now if I don't predict it, and if I don't know and it suddenly goes off, so all my process gets impacted in the process, and all the people and all the machines which are further down the line, right, in the assembly line, they're all sitting idle. So one of the best ways to solve it is probably using predictive maintenance, which could predict, okay, when is this machine gonna fail? If I can predict what are the components which are giving trouble, right? So those are some of the areas which predictive maintenance address. Second is predictive quality. Okay, as the name suggests, quality, it lies within the quality function of the business. So again, going back to the car manufacturing. So let's say done stamping of the steel coil into the auto body parts, which is a door, fender, a bonnet or something, right? So now when you do this pressing, because there's such a high force used, there could be cracks, there could be holes, there could be some other kind of defects within this body parts, right?
Right.
So yeah, so what happens is usually towards the end of the line, there are quality inspectors who kind of eyeball for the defects and then reject some of the pieces. Some of the pieces are again redone, and some of the pieces are definitely passed on for the next process. Now this is very cumbersome in terms of time, in terms of labor, because it takes around 1 to 3 months to train some of these laborers to identify, and factory works in a 24/7 fashion, right? So obviously humans are not designed to work towards the night, so there is fatigue, and then the performance drop happens. So if we could
Yeah.
automate some of this using a computer vision system where there are cameras, right, which can identify some of these problems, that there is a crack or there is a hole, and if there is a robotic arm which can be actuated, then saying, okay, there's a defect in this product, can we move this to another line? So that kind of brings in a lot of efficiency and optimization into the system, right?
Sure.
Next is efficiency solutions. So when we talk about efficiency solutions, so we're primarily talking about energy. So every kind of factory, irrespective of the kind of factory, it consumes energy for the production process, right? And the budget usually, or the consumption ranges from $1 to $5 million per month for a medium to a large size factory, right? Now, can we bring in efficiencies here? How do we do that, right? Can we optimize some processes? so that we consume less energy, because this is a solution which is applicable to all the industries within manufacturing, right? Now, and then there is digital twin. So yes.
Ravi, actually, you know what? I've actually been waiting for you to talk about digital twin here because this is a new buzzword I've been bumping into lately,
Okay.
and there has been a lot of hype about this concept, right? The digital twin, right?
Right, right.
And I understand that digital twin basically means digital mirroring of product behavior and so on.
Hmm.
But to talk a little bit about what it implies, like the implications and what the hype is all about,
Right.
sort of significance, and how will this affect the industry? So, when you're talking about digital twin, if you can kind of go over that also, I think it'll be a little bit
Sure,
very
sure, sure. Yes, Alan, definitely let me do that. I have few slides, in fact. Let me pull that up. In the meanwhile, so let me give a simple example. Let me take an analogy of you itself, right, Alan? So if I have to create a digital twin of Alan, so so what would I need? So let's say digital twin is actually nothing but a digital representation of an asset or a machine or a person or processes, right?
sure.
So if
Yeah.
I'm creating a digital twin of Alan, so what are the different factors involved, right? First could be form, which is height and weight, and how does Alan look, right? Then it could be the operational factors, right? Or what does Alan do on a daily basis? What kind of apps does he use? Is he on Facebook? Is he on LinkedIn? What are the productivity apps is he using, right? Then if you're looking of maintenance history, probably what kind of health lifestyle he has, what is his last time blood check reports, and what kind of different medical history does he have, right? And I can probably
Right.
use that to predict some of the cases. And then probably also what kind of transaction does he do with banks, or does he do with credit card, right? That gives some idea about what kind of behavior Alan exhibits. So on the same breath, when we do it do a digital twin for a physical asset or a machine, right? So what happens? So first is about form. So if you have to create a digital of a motor, let's say, right? So form is around how does the dimensionalities look. So we could use CAD CAM models. Then we can use maintenance history. When was it maintained? What is the next maintenance cycle? And then operational data, right? What kind of inputs are going to this machine? What kind of output is it throwing, right? Is it throwing a better output or not? Or what is the size of this output, right? How fast is the motor spinning? And then there could be a different readings, whether in terms of temperature, whether in terms of vibrations, right? And then we can definitely start putting together these different motors and see, okay, how are two different motors connecting, and how are they talking in a factory kind of environment. So that's when we start talking about different types of digital twins, right? So the first
Okay.
one is parts twinning, or the most basic fundamental block, right? So if you're looking at an engine, probably within an engine, is there a compressor? Are there gearboxes? How do they look? How do they talk to each other? What kind of data do they produce, right? That is the first level of parts tuning. Second is, if I bring together different parts, right? Within a car, there is a transmission, there is an engine, right? How are they all coming together? Can I leverage that data? Can I find the interoperation between these some of these different machine parts, right? I can, using this data, I can find out something like as mean time before failure, or a mean time to repair. So these are some of the KPIs which I can track using product twinning. Next is system twinning, where multiple product twinnings come together. We form something called as system twinning. So what is system twinning? Within a factory, let's say we were talking about different processes within a car factory, right? Are all these different machines talking to each other well or not, right? So that is system twinning. And on a last, the highest level of twinning could be process twinning, where we are not only looking at physical assets, but also the complete processes in the manufacturing floor, and even outside the manufacturing floor, and how do they all connect together, right? So as you start from top and go to bottom, it gets a little more and more complex. We start off with first
Sure.
engineering technological data, then probably operational technology, and then probably we start merging all this data with IT components, right? What are some of the key tech components involved within digital twin? So we use AI/ML, definitely. We need connectivity of all sorts, whether it's wireless, wire connectivity, what kind of protocols are these machines using to communicate. Then there are IoT sensors, right? I'm sure everybody would have heard of IoT. What is IIoT, right? IIoT is nothing but industrial Internet of Things. So here we have again temperature sensors, different kind of sensors which are used in the manufacturing context. Then we have cloud technology, and we have a different AR VR technologies to make 3D models. So when I'm explaining this, I thought this might be one more relevant slide to pull out to explain how does this communication happen within a manufacturing landscape, right? Because a lot of the folks out here might not have seen the actual manufacturing shop floor. So as we were discussing, there could be different kind of sensors on the ground, right? There could be pressure, temperature sensors. There could be viscosity sensors, so on and so forth. And then there are different kind of machines again. It could be CNC machine, it could be stamping, welding, right? All these machines then kind of go to next level and start communicating with, let's say, PLCs and RTUs, right? And then at the next level, they start talking to some kind of industrial PCs or a SCADA system. And this is where probably a human machine interface also resides. Between these, there are protocol conversions, there are gateways sitting, right, which is collating all this data together. And then this goes to a next network, which is probably historian, which is where all the data resides. So you can look at it like a data repository where all the time series data comes and sits. And eventually, all this data starts communicating with your ERP and other business applications. And that's the structure of this communication, probably.
Sure. Okay. I mean, I think as exciting as this was, it got a little less creepy as we started explaining more about, the auto parts and less about my example, right? So this is some of the future technology that we're seeing that is going to be a big thing now, right?
Right, right.
I actually have a few questions lined up for you. Would you prefer to take them now, or would you want to just do that at the Q&A section?
Definitely, we can what we can do is now probably we can move to some of the cases or some of the use cases which Affine has
Perfect.
demonstrated.
Yeah. Yeah.
So
Yeah.
that
Yeah.
way we understand how does it practically work, right? And what is there for manufacturers out there, right? We've
Sure. Yeah.
spoken about different concepts, but what are the applications of it, right? So we can probably
Definitely. Yeah.
discuss one or two, and then if time allows us, we can definitely
Yeah.
take more
Yeah.
and more questions, right? And I would
Sounds good.
request
Sounds good.
all the users to please drop in comments. We will definitely take those questions. If not now, we can definitely respond to it later. Okay.
Yeah.
So
Yeah.
yeah, with that, I'll quickly cover one or two use cases probably. Right. So one of the uh, uh, interesting use cases which we have done is for an energy major. So so this energy major had it was wind energy which this energy organization was producing. So wind turbines are usually placed away from a urban scenario, and they are in remote conditions. So with this remote condition, there are more challenges. What kind of challenges do we face? One is if there is a failure of equipment, so the turnaround time to fix this and for a maintenance engineer to reach this remote condition takes time, and the downtime prolongs, right? So how do we address this, right? So wind turbine has different components like blades, rotors, controllers, generators, anemometers, gearbox, so on and so forth. Now we collated all this data. We kind of sequenced using different IoT hubs. So we have historical data for all these different components. What kind of data do we have? We could have the oil temperature data, we could have the weather data, we could have the speed of the rotor, right? Or we could have the voltage and current fluctuation data. So these are the parameters which we had, and using some of the technology stack like Keras and TensorFlow, we built machine learning and deep learning models which could analyze this historical data and then kind of identify anomalies, right? So on the left bottom, if you see, there's a graph. So if let's assume oil temperature is one of the critical factors. So these models identify what is that critical value after which if it goes higher, there is a high chance that my generator fails or my controller fails, right? So then these alerts are generated and then there is a service ticket raised so that the maintenance engineer beforehand goes and checks it out before actually this goes the wind turbine goes down and it causes some kind of bad effect on the grid
Right.
altogether.
Yeah. Yeah.
So what are the advantages eventually? So when we deploy this kind of problem, obviously the machine time downtime reduces, right? We reduce the maintenance cost because we could preempt and proactively solve the maintenance issue, and that eventually costs in better savings and more uptime, right? And definitely we have also tried to reduce some of the manual interventions, and this way we are more proactively solving the problems than taking a reactive approach, right? So this
Okay.
is one of the problems which we had solved for energy major. And let me take you through one more example. So this was in context of defect identification, which we're speaking when we're talking about predictive quality, right? So using computer vision for a CPG client in Germany. So this CPG client manufactures sanitary pads. So when you make these products, there are close to around 100 to 150 products made per minute, right? So there's a knife which kind of cuts across the edges and so on and so forth. And there are again challenges or defects uh, in terms of crack, or there could be tear or holes or folding, right?
Mm-hmm.
So again, a visual inspector seeing them and inspecting them takes time, and it consumes a lot of energy, right?
Sure. Yeah.
So
Yeah.
we automated some of this process using a camera and a computer vision system where a computer could identify some of these defects, and they could even categorize what kind of defects they are and localize where exactly the defect lies. So this could
Mm.
automate the complete process and definitely bring in a lot of optimization. So again, we used a similar tech stack here with Python and TensorFlow, and the images repository was again analyzed, and we had built deep learning and neural network models to kind of identify some of these defects. So those are
Okay.
the AI models which we use, and yeah, that's how this went. And the third one, which I want to cover now, is probably around predictive maintenance using sound, right? So this was a very interesting case study. So this was for a textile manufacturer, because till now we were talking about image kind of a data or a machine prepared data, right? So
Yeah.
here
Yeah.
we could from using the sound from the gearbox of the machine, right, we could predict whether the machine is going to fail, or is it, does it need some kind of repair. So the AI engine works very similarly, right? But the input files were the sound files this time, and very interestingly, we got very good results from this exercise, and we were 90% up to 90% accurate in terms of detecting uh, when the machine is gonna fail or the gearbox is gonna give issue based on what kind of vibrations we are getting or what kind of sounds we are hearing. So these were some of the challenges which we solved. Probably one last one I would take, because auto is again one of the focus areas within manufacturing, right?
Sure. Yeah.
So this is what we did for a German automotive. So there could be corrosions in the different body parts, right, when they're exposed to different weather conditions. Now, how do you identify some of this? Again, it could be a manual process, or you can build some kind of AI deep learning models to identify whether there is a corrosion, what kind of corrosion, what grade of corrosion is it, and where is it located. All right. So we could uh, create models which were giving up to 80% accuracy, and it definitely uh, uh, shortened the time for this QA process. So those were some of the learnings which we have, and these were some of the case studies I thought would be good for the audience uh, to showcase. And definitely we have much more. So if you are a manufacturer or a business who are facing any of these challenges, please write to us, and please check our website for more updates. So we have demonstrated some of these solutions. So it will be great to it will be great starting point for us to discuss what kind of problems you're facing, and then probably go on and discuss on how to solve a problem.
Sure, Ravi. Thank you so much. So going kind of back to just these two case studies based on how you identified problems with the sound and the predictive maintenance based on the energy consumers. So what you're essentially saying is that we have more energy, we have better performance at a fraction of the time and cost. And it's about time we all started moving in this direction, right? So, do we already have these kind of technologies installed, or like how soon do you think we'll be seeing them in the near future?
Okay. So to answer that question, then, so it depends on the digital maturity of the organization. So some of the cases
Right.
like predictive maintenance are definitely low hanging fruits, and definitely different manufacturers should explore. But depending on what kind of data are they capturing, and as I mentioned, the Industry 4.0 journey, right? So if the connectivity between the machines is not there, probably that is a good starting point first. Then probably
Right.
connectivity,
Yeah.
value
Sure.
chain, and then once you have start generating the data, like for any AI or analytics model to happen or for it to perform, right? You need data as a starting point. So probably connectivity is the first problem which a lot of manufacturers are solving. So we have definitely solutions in that space as well. We understand that space well, how to connect different machines. And then once we have connectivity between different machines, how do we leverage this data? And within data uh, monetizing or value realization of data also. Probably visualization plays the first role where you monitor how some of this data is working and how some of these parameters are fluctuating. And then probably you do analysis and then probably AI model comes towards the end, right? So that's how the data value chain or the value realization also happens. So that is
Perfect.
a
Yeah. Yeah.
good process to follow and a good direction to take.
Okay, perfect. That was wonderful. I don't think anybody could have explained it more detail, right? I'm sure everybody would agree that it was a wonderful session. We're kind of running a little bit short on time now, so I think this would be a good place to break for some Q&A. What do you think, Ravi?
Yes, definitely. Thank you
Yeah.
very much,
Okay.
Alan. Yeah.
All right, guys. We have a couple of questions lined up. Feel free to keep shooting them in the space provided, and we'll answer as many as we can. Ravi, to quickly go over a question that we have right now.
Mm.
So, in terms of predictive maintenance, what kind of data would be required? Is this variable for large industries, or how do you think that kind of changes?
Okay. So depending on what kind of components we're dealing with, right? So when we're talking about wind turbines, because wind turbines would have different components as we were speaking, right? It could have a rotor blade, it could have a generator, controller, so on and so forth. And then what kind of data can you get, right? One is definitely the weather data, right? What speed
Sure,
is my wind turbine moving at, right? What kind of power is it generating, right? What kind of voltage and current fluctuations are we seeing? So this is some kind of data, and then definitely there's oil temperature. Oil is used for uh, the smoothing out the mechanical process, right? So what is the oil temperature within? And there are definitely other sensors also involved. So we get all this data and then probably try to analyze which are the critical parameters which are fluctuating more, right? And probably we see how what is the variance across time, whether in a day what kind of variance is there, and in changing weather condition how does it vary. And then probably we the AI model also is smart enough to learn some of this. And then obviously there is a parameter tuning done by the AI engineer to ensure that these models perform well. So that's the crux of it.
sure, sure. Okay. I actually have another very interesting question about IP rights as well. So this
Okay.
is again with regards to predictive maintenance. So the question is, would intellectual property on algorithms pose threat to competitors, especially small and medium scale industries who cannot afford to buy the IP rights, or is the grounds going to be even for all with respect to using the technology?
Okay. Okay. If you don't mind, could you repeat that question again, Al?
Sure, sure. So with regards to predictive maintenance, would
Right.
intellectual property on algorithms pose a threat to competitors? So especially when it comes to small and medium scale industries who cannot afford to buy the IP rights,
Okay. Not
will the
really.
grounds
I
be
would.
mooted?
Okay. Okay. I think I get the gist and what direction you're going. Right. So
Right.
one is so in terms of standardization, right? So some of these solution components are pretty standardized, like processing the images in a computer vision kind of system. To some extent, there is standardized, and some of them require a customization. Like if we're speaking about uh, images for a sanitary pads, the AI model could be a little different. When we're talking about the corrosion detection, because the type of corrosions can change, so then there has to be the customization of the AI model. So again, each problem is unique, and everything has to be tailored to the problem. But again, I wouldn't call it a very expensive solution per se. So
Right.
we
Yeah.
work with a lot of small and medium enterprises as well. It's just that the first requirement is probably data. So if you have data capturing abilities, we can definitely start off with the AI journey. Even not, we Affine has definitely capabilities through its ecosystem where we help uh, set up systems to capture some of these data. So it's not really difficult for a SME kind of a industry player to kind of participate in this journey. So this is for everyone, right? Industry 4.0 is not only for large players.
Sure.
Yes, large
Yeah.
players are
Yeah.
leveraging it more, but again, it's very imperative to move to this direction, because that's when you start gaining benefits from it. And as world is digitalizing every aspect of a different business, whether it's a digital e-commerce business or it's a consumer business, even manufacturing businesses have to take that direction to probably reap some of
Definitely.
these
Definitely.
benefits.
Yeah. 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 For sure. Okay, I think people would be sending in more questions. They'd probably be reaching out to us.
Sure.
I think you're kind of on time here also.
Okay.
So I
I
think
guess
we'll
go ahead.
kind of do a wrap, right?
Right. Right.
Ravi, so I'd like to start by thanking you for spending this time with us. We sure hope to see you again. Um, Guys, so to tell you a little bit more about Ravi as we conclude, he's an AI practitioner with an entrepreneurial background and over a decade worth of experience in analytics. He's worked extensively on telecom and high-tech domains for users in US, Africa, among several other locations. And he wants to bring what he's learned, investing his efforts to molding the future of the manufacturing sector. And as you can see, he's super friendly and open to discussing your manufacturing queries. So feel free to look him up on LinkedIn. Get in touch for more information about today's session or anything about manufacturing that you generally want to talk to him for. And for more interesting topics you would like for us to do in our upcoming sessions, leave them in the comments or get in touch with us at marketing at affineanalytics.com for more manufacturing updates and our 10th anniversary celebration. Thank you again for joining us today. Wishing you all a wonderful evening. I'm signing out. See you all next time. Until then, stay safe, stay tuned.
Thank you,
Thank you,
guys.
Ravi.
Thank you very much.